This is coordinates tutor. Pick a coordinate by breaking a block, and it thinks, the coordinate is -2, -2. And sure enough, since the cyan block is at the origin, it's -2, -2. Okay, let's do one more. Thinking, and there it is, -2, 1. Right there, sure enough, 2 back and 1 over. So let's take a little tour of this grid. Okay, there it is. So in Minecraft, we think about this direction. This is east, and east is, think of that as positive x. West, which is below the origin, we think of as is -x. Z, which is the coordinate to the right when the player is facing east, is south. And minus z is to the left, again, when the player is facing east. Okay, now, on this grid, the cyan block is at the center. So the block in this far corner, which is the positive coordinate, would be, what is it? What is it? Let's go see what it is. What is that? Okay. It is thinking. And thinking some more, and thinking some more. There, it is 5, 5. And at this coordinate, which is the, it's the negative z, but positive x, and it's going to be what? Thinking. 5 minus 5. So that would be positive x, which is to the east, and negative z, which is to the north. And of course, there's 2 more corner blocks. What is that one? Thinking, I'm not gonna, there it is. -5, 5. So -5 is to the west, so that's behind us, and down from the origin, and 5 is to the right, which is south. Now, there's one more corner block. Might as well do it for consistency. And it wanted to, whoops, it got that one immediately. So that is -5, -5, which means -5 to the north is a -x, and -5 to the which is to the south, so it's is behind us. Oh, I'm sorry. Did I get those mixed up? Okay, this position -5, -5 is the left -5 is the east-west coordinate. So -1, it means it's to the west, and -5 which is the second coordinate, is the north-south coordinate, so it's -5 means it is to the north. Okay, then the axis of our XZ grid is indicated by, of course, the cyan block, but these little white blocks at each end and to the side. So that's our XZ axis. Of course, in Minecraft, a coordinate has three factors, and the middle one, which we're leaving out here, is y, which is the up and down, but because it never changes, we're not using y. We're only using an x, z grid. Okay, let's see this start from the beginning. Okay, we move to a new position. It reminds us that x and z, and it's all is the same as east and south. X and z is east and south. And then it stops there and it waits for us to break a block. Well, let's just break that center one. Look at that. Thinking, thinking, thinking. Now, why is it taking so long to think? Thinking, 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 thinking. Oh, it found it. 0, 0. That's where it should be if it's at the origin. So let's do one more. Thinking, 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 thinking. Oh, I got it. -3, which is down 3, and across 1. -3, 1. Okay. So why does it take so long to think? And watch over here. We're going to do that one. Wow, it got it immediately. So that's a -5, -3. What it's really doing when it's thinking is the program is searching each grid here for air. Notice when we break a block, it leaves air. And when it finds it, it turns the air, it replaces the air with a green block. There it is. And then it knows where the coordinate is. Cool. Okay. Now, that was fun. Let's look at the code. Oops. Thinking. Oh, I got -2, 0. Okay. I'll go quickly through the code because the blog post at MakeCode.com thoroughly describes the code. But we start the code by typing run. We call the function move, which moves us to a pristine new location in the Minecraft world. We call the function setOrigin, which starts out actually where the player is, and that's that cyan block I've told you about. There. And it marks that because it sets a variable called origin. And we use that as a reference point in the code for building the grid and for calculating the coordinates. We call a function called setPrintPosition, which sets the position in the sky of the leftmost print position when you're printing from left to right. Then we run a command called compass, and because we run this as a command so that it will print compass, the north, south, east, west in the sky, but it won't wait for it. Compass will go off and print the compass, and we'll keep on running. It will also go off and print brackets, but it just goes right straight to function canvas, and those are running in the background. Canvas refers to the stuff that is put on the ground. So that would be this beautiful white stained glass grid that we use as our coordinate area. After we get compass, then it flashes X, Z, E, S. And remember, that's when it showed in the coordinate area, it showed X, Z, then E, S to remind us that those two things are the same. Then nothing happens. Well, let's go see that again. So if we're over here, run. Okay, there we are. It's doing the compass in the sky. It's printing the brackets. Then it's printing XC and then ES. Then what happens? So it did this flash to print thing to print XCES. And I call it flash because I've experimented. I have a loop in there that lets me print those two in a cycle as many times as I want. Like there could be 2 or 3 copies. And but I grew impatient, and okay, we're going to Okay, so now the program seems to have just stopped. It's sitting there with showing that ES waiting for us to do something, no doubt. Waiting for us to do something. So nothing is going to happen until we break a block. Okay, we broke one. Then the question marks start flashing while it's searching the grid for the air. And it found it, put green there, and put the coordinates in the sky. Now, the program gives you all the time you want to study the answer, which is marked by green. And sure enough, it's my 1. See, that's 0, so -1, -2. That's the left coordinate, is the east-west. And over 1, 2 is the z coordinate. And so it's -2, 2. And nothing happens until we break another block. Okay, thinking. There, found it, yay. And so that is -3, 0. Why is it 0? Well, because it's on this axis. It's right in line with the cyan block. Okay, let's look at another piece of code. So now remember, once we finished with the run, it then waited for an event. Well, it waited for something. It was waiting for us to break a block. So these 3 block events are waiting for us to break one of these 3 color blocks. Once one is broken, then it runs this code in the do broken event. What that does is it uses a Boolean variable called error found to false, and it launches this flash Q, which means flash those question marks, meaning thinking, and it runs that, in parallel, that is at the same time as this function find error runs. Find error searches that entire grid until it finds where the error is in the block where a glass block would have been. When it finds error, it sets this variable error found to true, and it stops flashing, and of course it then runs post coordinate. And what that does is, I'll come back to those. Post coordinate is where it goes through all this gobbledygook in order to print X and print Z in the sky. The gobbledygook just is positioning the coordinates depending on whether or not they're positive and negative, and so that they all line up correctly. Now, and so once it's finished with that, what does post coordinates do? Well, it does nothing. So what happens? It's waiting, it's showing the coordinates, but nothing happens until you break another block and those events run again. Okay, let's look at the find error routine. It's kind of cool. And let's make it large so we can see all of it. Find error, what it does is it runs this 2-dimensional loop on X and Z. And it runs them from -5 to 5. And it has a position which is the try X and try Z, and it calls the function test try position to see whether or not there's error. So when error is found, because of the way it's testing this error found Boolean, when error is found, it stops running this loop and exits and goes back over to post coordinates because we found error. That's easy enough. Now, test try position is probably the most difficult program to understand in here. So this is the if test for error at this position, origin plus try position. Remember, try position is the coordinate within the grid, which can be -5 to 5 and -5 to 5. And so we have to add that to origin to get the Minecraft location in the grid, which we test for error. Okay. And then, so error, if we find it, we set error position. If we don't find it, We just exit because the routine that call this will post coordinates will indicate that nothing was found and print some red question marks. And of course, that should never happen because unless this test for error fails, and blah, blah, it should never happen. So test for error, when it finds error, is we want to know if that error position is at the origin. Why do we want to know that? Well, we don't want to turn the block green. The broken space, we don't want it to turn green because then we'd lose track of where the origin is. So we want to test if it's the origin and put the cyan block back. And if it's not at the origin, we put a green block. Now, this is kind of a convoluted way to test to see if we're at the origin, but basically if the trie-x and trie-z are both 0, which is what this is testing, then we're at the origin. I have this broken into two pieces where I set a Boolean variable called b first and test it in the if statement. That's to in order having the if statement be way long, because when it's way long and I put it into my blog, it shrinks it down so small in order to make the width I can't read it. Okay, enough of that. So now after it does that, it sets these two coordinates called error x and error z to whatever trie-x and trie-z would be, and it sets the position, it sets error found to true. Okay, now this function says, call the function, is there a bug in MakeCode? Well, I'm not going to go into that right now because I'm pretty sure there is a bug in MakeCode having to do with how you test two positions against each other. I'm documenting that probably by tomorrow in another blog post in a simpler program, but because it's interesting, I left the code here for those ambitious souls who would like to study it. Okay, that then is, oops, I'll make this pretty. Okay, that is, okay, I'm grandma, I forgot what that is. Oh yeah, that is coordinates tutor. I hope you enjoy it. Bye.